All right, where's my screen? There we go. So for assignment number 6, you're given a table. It's a little confusing. I'm going to help you through it. So it's an even function. I sketched it over here to the right. So I started with the beginning part, which is just at 1, the answer, when x is 0, the answer is 1. So here we are here. And then when it's at 2, it's -1. And notice, at 1 the answer is 0. So right here the answer is 0. And then at 2 it goes down to -1. Now why did I go up from there? Because the derivative is positive after that. So it goes down. But it stays negative. Whatever this is, it goes up, but it doesn't become positive. And then it says the word even, which means whatever the picture is here, it reflects over on the other side. So they match each other on both sides. And the question is, does it reach a maximum? The answer is yes. And so there's an absolute maximum. It means there's one point higher than all the other. And when does it occur? At x equals 0. Put this down. Are there minimum? Yes, there's an absolute minimum. So where's the lowest point of the graph? And it's at 2 and -2 because they mirror each other. Find the x-coordinate of each point of inflection. So when I look off the table, point of inflection is the second derivative. So going to the right, it's going to mirror to the left. So we're going to talk about that in a second. So going to the right, from 0 to 1, it's positive. From 1 to 2, it's negative. And then from 2 to 3, it's negative again. So I'm looking at 1 being a point of inflection because there's a sign change there. Now this gets reflected. Now when it's reflected, I want you to look at this. What's on the right has a negative, but what's on the left is a positive. So when it reflects, it is actually going to change the sign. So this reflection makes this negative, this positive, and this positive. So we have a sign change here at -1 and at +1. So at x equals positive and -1, there's a point of inflection because there's a sign change for the second derivative. All right. And this is sketch. Oh, I did this one right here. Here's my cute little sketch in terms of sketching what it would look like. And I made these corners because the derivative was undefined at 2 and it was undefined at 0 and so on. So every time it was undefined, I made a corner out of it. All right. The next one, right here. So the figure above shows the derivative from -10 to 10. It says, what values of x does the graph have a horizontal tangent? So a horizontal tangent is another word for a turning point. And this turns when the signs change. So we have a turning point at -7, a turning point at -1, a turning point at 4, and a turning point at 8. So again, it was -7, -1, 4, and 8. So again, a turning point is when the derivative is equal to 0. That gives that turning point maximum or a minimum. Part B, for what values of x does f have a relative maximum? So a maximum is when it goes from positive to negative. So -1 is a maximum, and positive to -8 is the other one. Is C minimums? No. Oh, and if you would justify your answer, you would say at x equals -1, the derivative So it goes from positive and is negative after, right? Oops. So it goes from positive to negative at those numbers. C, for what values of x is it concave down? So concave down means when you look off the derivative that it has a negative slope. So this is concave down, is when this has a negative slope to it. So do we know, I mean, are we assuming this is -3 and 2? Maybe. So from -3 to 2. And where else is it negative? So let's say it's from 6 to 10 is also a -1. So this is when the derivative is negative, when you have a negative slope. That means it's concave down for the function. So a negative slope for the derivative means it's concave down. And really what you're looking for is the second derivative is less than 0 there. So you're looking at that negative slope. All right, turn the page. So you're given a graph here, and this is a semicircle and some line segments, and it says let g at x equal that. Now this is what you look, this is f, and so g is being defined with the integration of f. Integration means area. So if I'm asking for g at 3, plug in 3 for x. So let's make sure we write this down. And again, part A, what does g at 3 equal? So we're integrating from 0 to 3. So that means off the graph, what's the area from 0 to 3? So from 0 to 3. So from 0 to 2 is a quarter of a circle. That's 1/4 pi r squared. And the radius is 2. We don't have to simplify it. Minus. Now, why am I going minus? Because now the area is below, and we're just looking from 0 to 3. So we're looking at a little triangle here. Half the base times the height. That's 1 and 1. And there it is. We don't need to simplify it. All right, the next one. Find all x values from -2 to 5 where g has a maximum. So g has a maximum when you take the derivative. Now, the derivative and integration cross out, and it just becomes f at x. That's important. And I want to know when that derivative, f at x, is equal to 0 off the graph. So not the end point. So at 2 and at 4. And which one would be the maximum? Is that what it's asking for? So the maximum is when we go from positive to negative. So at x equals 2 is the relative max. That's where it changes. So g at x, g prime at x changes from positive to negative. That's what creates that maximum. All right, next one. Write an equation for the line tangent to the graph at x equals 3. So, this is for f at x. So x equals 3 off the graph. I see y equals -1. Now, it's undefined there. So let me see what that means. Oh, it's to the graph of g. So x equals 3. And then what does g at 3 equal? This is the y value there. So 4 take away a quarter, that's pi minus a half. Oh, I need that. So this is pi minus a half. That's the y coordinate. So g at 3 equals this. We found that from up here. That's common with these AP exams. You gotta go back and take an answer you did already. And then what's the slope there? So the derivative of g is just f at x. So what is f at 3? That is the slope. And then put this together and you get negative 1 x minus 3 and then the y coordinate. And there's your tangent line. A little bit tricky, right? All right, part D. Find the x coordinate of each point of inflection. So again, we're looking at g. We just said the derivative of g is f. So to find the point of inflection, we need the second derivative, which is the derivative. And we're looking at where the derivative is equal to 0. Where's the turning point? So for f, where's the turning point? I see one at 0. I see a turning point. The other one is undefined at 3. No, I guess that doesn't matter. All right, and so 3 is the other one where there's a turning point here where it changes signs. So at 3 and at 0, things change. So at those, we have a point of inflection in terms of figuring it out. All right, 2 more. The figure below shows the derivative of f. The derivative of the function on the close from negative 1 to 5. The graph of the derivative has horizontal tangents at 1 and 3. So those are turning points. The function is twice differentiable and f at 2 equals 6. Find the x coordinate of each of the points of inflection of the graph. So to find that, I need the second derivative, which is the increasing, decreasing turning points. So we have a point of inflection at these turning points. So at 1 and at 3 are point of inflection looking off the first derivative. And then you write down, why did you say that? So it changes sign, it goes from increasing to decreasing, and understanding the connection there. Part B. At what x value does f attain an absolute minimum, and what does it contain its absolute maximum? So whatever the value is here, all of this is decreasing. It's negative. And this is negative. All of it is negative. So when you think of this area and this area, all of this is decreasing. So the absolute minimum is right here. It decreases, and it stops decreasing when the velocity or this first derivative is positive. So at 4 is a minimum. And then where is the maximum? Well, if you think of the area here after, this is increasing. But whatever the value was before it did all of this decreasing is the answer. So at x equals -1, we must have had a high value that went down, 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 and then it went up a little at the end after 4. So whatever this value was at the beginning before it decreased, and then at 4, it increased a little, but not so much of the decrease. Whatever it was at the beginning must be the absolute maximum. Part C. Let g be the function x times this function. Write and find an equation for the line tangent of g at x equals 2. So x is 2. Y, I'm going to plug in 2 for x and solve it. So x is 2 and then f at 2. So f at 2 is equal to -1. So it's 2 times -1, so it's -2. And then the slope, I need to know the derivative of g. So that's the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. So I'm going to do the product rule for the derivative, and then I plug in 2. That's 2, the derivative at 2, the function value at 2. So now I need to look off the graph for those. So in the question it says the function value at 2 is 6. So I'm going to do that. And then off the graph, what's the derivative at 2? Oh, wait a second. Yeah. I did this part wrong. So f at 2 is 6. So when I plugged in 2, this should have been 2 times 6, which is 12. I looked at the derivative instead. Now the derivative at 2, now I can look off the graph and see the derivative at 2 is -1. So we have -2 plus 6, which equals 4. And now I have the 3 numbers that I need. So we have y equals 4, x minus 2 plus 12. There it is right there. All right, we got one left here. The graph of the function f consists of 3 line segments as given above. So this is connected to this question. This is f. This is f right here. And then g at x is defined using that. Okay, let's really think through this. So can you find g at 4 and g at -2? So we're going to plug in. So let's start in a good way. So we're going to write down the equation for g at x. Goes 1 to x. And then it says for part A, what's g at 4? So we're going to plug in 4. Now, what does that mean? What's the area from 1 to 4? So let's look off of it. So here's 1. All right. So, and I remember positive and negative. So this is a trapezoid. You don't have to simplify it unless we have to. So half of the base here, which is 1, and then the 2 heights. So that's 4 plus 1, which is 5. And then the triangle, that's 1 and 1. So half of 1 and 1, it's a half. And then minus, because the next part is below, again, that's 1 and 1. And here's the truth, that they cross out, right? So 1/2, take away 1/2, cross out. So this answer is half of 5, or 2.5. The next one is g at -2. So we'll plug in -2. Now, when the top limit is smaller than the bottom, I'm still going to find the area between those numbers, but whatever answer I get, I'm going to make it negative, or I'm going to change its sign because the limits it. So if I wanted to, I can flip this around by making it negative, and now it is proper. So this is improper. I can flip it by just make it negative in front. Now it's proper. So whatever answer I get, I'm going to have a negative in front. All right, from -2 to 1 is just one big triangle here. So that's what? 3 and 4. So what is that? 6. So the answer is -6. All right, part B. Instantaneous rate of change means the derivative at 1 of g. Okay, so g at x is equal to this. This is going to be big. These questions happen all the time. The derivative of an integration, they cross out and you just plug x in. And so the derivative is just f at x. And then at 1, I plug in 1 to get my answer. So I just need to know the function value at 1. That's equal to the derivative at 1. So that answer is 4. All right, 2 more parts. Find the absolute minimum value of g on that from -2 to 4. So we already know at -2, the value is -6. This is from here. So at -2, it's -6. At 4, the answer is 2.5. Is there another one to look at in between? So from -2 to 3, so this is positive area. So from -2 to 3, it's above. And then from 3 to 4, it's below. So that means it increases, and then at 3 it decreases a bit. And we're asked for the absolute minimum. So the absolute minimum has to be like where I started. So it increases and a little decrease. So I know where the maximum is, but the minimum must be like where you started before you start increasing. So it must be at -2. So -6 then is your absolute minimum. You have to think of the endpoints, and as if there's a sign change here at 3, that doesn't even create a minimum. So the lowest must be at the left endpoint, which is -6. Last question. The second derivative of g is not defined at x equals 1 and x equals 2. How many of these values of x coordinates of points of inflection of the graph of g, and then justify your answer. So we're going to do a let's come back here. So do you see how the first derivative is equal to f at x? So the second derivative, which is what we're looking for, is equal to the derivative of f. And where is that equal to 0? So where are the turning points? Well, where's the derivative equal to 0? So the turning points. So we have one at 1. And do we have any other turning points? I only see the one at 1 to be the turning point. So it increases and then decreases. There's a sign change there, and that's it. So the point of inflection is at x equals 1. All right. Mr. G Math will burn out. Great job doing your calculus today. We'll keep working at it in class together. Till next time.